server to the test server. You can test things there without having to compromise your production server. So that's good, especially for people that have Drupal installed in the managed web servers. When they Drupal, really bad things happen. So it's better that you can test it before, and if it goes right, you clone it back to the production server. So architecture looks like that. We will go one by one to see how we build it. Be aware that this did not talk about OpenStack, neither about Docker, so don't expect any of that. But we use most of them are Python technologies, and we did that project in a few months, where it's still not finished. We are still working on it, but most of it, we have done it by using 1.2, 1.3 FTEs. So it's not much people. So the amount of resources that you require for doing it, although it seems like a huge service, it's not that big. So we have here the VM architecture. Here, the VM is separated. The VM service is separated from the rest of the stack. So we start describing the VM architecture. The VM architecture is just a VMware solution. You may know these VMware solutions. It's just a ESXi servers, and you can manage these XCI servers using vSphere control panel and some APIs. And we have external backup server where we do the backups, but it's not replicated. So if something happens, then we rebuild the VM and recover the things from the backup server. So the flow is easy. A user enters to the Django web panel, authenticates, so we know who he is, and then he asks for a new managed web server. A host name and an IP 6 and 4 are allocated to this site. The VM API creates a new VM. The VM API installs the OS, and when the OS is ready, Ansible is executed, and Ansible is the one that configures the whole machine. So we are using Ansible as a configuration management, and it does everything we need. For those that doesn't know Ansible, it's just a bunch of things together. They are easy to script, so it's very easy to understand what they are doing. And they separate into folders, which is really good, and you can find the file that you are looking for, and there is separation of things in the different files that you can see. So it's pretty good to use. It also has inventory, so you can define all your servers based on dynamically or static, so you can have a file with all your servers, or you can inject the output from another API as a list of servers you have, or even the database, etc. So it's pretty nice. It works really well. And it's based on playbooks. Playbooks is just a bunch of roles linked to a bunch of targets. So you have a roles, and definition of role is things you want to install in this role, in these machines that have this role, and then you have targets, and then you say this target, these machines, I want to install this role, for example, a web server. Web server can be a role, and the web server role has a lot of tasks that install Apache, configure Apache, etc., etc. This is an Ansible playbook. As I said before, you define the host where you want to install things, and then you define the roles that these machines in this list will have. For each role, you have tasks, templates, which are Jinja 2 templates, scripts, handles, and variables. You can have also global variables or variables entering into the script. And this is how a role looks like. It's just a bunch of tasks inside the role. You can see that here we're installing packages. It's a YAML file, as you can see. And it's pretty easy to understand what you are doing. So if you have you're working with more people, it's easy to modify the file, change the configuration, etc. You can see here that the templates can be used with variables, Jinja 2 templates. We use variables there, and therefore we use the same templates for all the configurations, all machines. You also have handlers, which are basically callbacks. When some function in Ansible is executed, then and you have a callback later, and you can, for example, if you have updated the Apache configuration or your Django app, you can restart Apache, and the callback is cool. So this is from the VM part. We use this VMware infrastructure. We use the APIs. We launch it. We create the VM. Everything is good after that, after Ansible configures the machine. And then we can offer the service to the user. So if we start from the top of the stack with the authentication part, we have our own authentication. We use Raven. Raven is our authentication service. So you can see that we have a lot of services interconnected using a lot of APIs. It is based on a WebAuth API. And we have to build a custom Django backend. But this could be substituted by any authentication that you can use. You can use the Django one if you want. You can link with your own enterprise if you want, et cetera, et cetera. So the second layer is authorization. We have like a kind of an LDAP-ish service. It's called Lookup. And then what we have there is just a list of users and a list of groups. We can see these users if they belong to which institutions they belong to, which groups they belong to. So the end user can configure their MWS server based on this list. They can search for another users, authorize them as administrators, authorize by groups, etc. So it's just a basic list. We use that instead of using the Django groups because it's more useful for us because people is using the university to this LDAP service that we have. So they create the groups there, and they are automatically updated if someone leaves, et cetera, et cetera. So when the user has authorized the user, another user to enter to the machine or use the service, we need to still to install the user into the machine. So we have another service over there called Jagto, which provides more information about users. It's like a user identity management. So we get from Jagto a unique UID from the user. We need that because if we install the same user in different machines, we still need to identify the files that belongs to him or to her in different machines. So they have the same Unix UID, and we use this Unix UID in all the user installs. User is installed using Ansible as well. It's installed in all the VMs where it is authorized. And we have periodic refreshes to refresh the lookup groups we have authorized. So if the groups change, people different change. And we allow people to upload their own SSH keys. And the SSH keys is also installed in the user configuration. So they can enter either using their password, which is checked with this LDAP server, or either the SSH that they have installed in the panel. So once they can access to the Django panel and they have the user installed in the VM, they can already access the machine. Everything is configured for them, so they can start using it. For previously, we had also another communication with the IP register API, which is on the bottom there. And this allows us, this is another external service. So as you can see, we have the main service, and then we have a lot of other services that we communicate with, which provides the university a registration for Kamacac domains. So if you want to register a new Kamacac domain, for example, importantstudies.kamacac, you can launch an API. We launch an API request using the same Django panel. Django panel sends the request, and then we get the domain name alias for that site. So everything is configured automatically. The user doesn't have to worry about the process, the internal processes. This API tells us if the user is authorized for that domain name, or if this domain name is already in use, etc. And the same API also provides us from IP addresses. We have to pre-allocate some IP addresses together with the host name. So when the user requests a new site, he can access directly using the domain name without having to wait for a DNS refresh. So what we do is just pre-allocate some addresses, and then when the user gets their site, they can access directly using the host name without waiting for a DNS update. We use two IP addresses. We have one addresses, one host name as well as a host address. So the communications for the host, and another for the service. So if we want to move the service to another machine, we can do it without having to modify the host name or the host of the machine. So we can separate what is the service and what is the host, and we can move the service IP. And you will see this is useful later. Additionally, we have SSHFP records and DNSSEC. Anyone knows what SSHFP record stands for? No one. Good. This is to forget about that. I'm sure pretty much you all have seen this screen like that. And what it does is you can upload an SSHFP record into the DNS with your public host key, and then and if you have DNSSEC activated, you don't have to check the host fingerprint manually, because the DNS server does it for you. It gives you, the DNSSEC gives you the fingerprint, and then when you connect, you check that this fingerprint is the one that is in the DNS server, which is secure communicating with you, and then you don't have to check manually if the fingerprint or the machine you are connecting is the one that it's claiming to be. So that's pretty useful. As I said, we have a lot of services in the same architecture. We have an inventory there, which is using another API. It's based on JSON API, on pull, consume. So we give to this service called BES the data of all our services, so we can use it as an external database as well. When we know where all VMs are, we know where they are located, the IP address they have, et cetera, et cetera. So it can be used even as an inventory for Ansible, or it can be used for other purposes. So as you saw, we have a lot of APIs, different ways of accessing APIs. We use SSH APIs, REST or non-REST, HTTPS, using JSON, non-JSON. But we have to deal with a lot of them in an async way, because we don't want Django, the main thread of Django, be stopped by that. So what we do is executing as a background processes using either cron jobs, which is the easy way if you don't need the API executed just after the user has launched the petition, or if you want